Alright, so here's a nice problem. We have something called Hadamard's Inequality, which is given by this. Now this problem also asks, in the textbook it asks you to give a geometric proof of this inequality, and we're not going to do that. So anyways, ignoring that part, what we're going to do is, well, this comes from the section on QR factorization, so you think maybe that will be useful, and it turns out it is. So let A equals QR be the QR factorization of A. Q is unitary, so its determinant is 1. So the determinant of A is the determinant of R. So how can we try to figure out what the determinant of R is? Now, if you go back and look at the textbook, you'll see that, and they talk about this, the norm of RJJ for any J between 1 and M is going to be the 2 norm of AJ minus this sum here. But because Rij, for J strictly less than I, or wait, is J less than I or is I less than J? Well, whatever the case, this becomes this, because that's how you get the Rij's. You take Qi star, yeah, I needs to be strictly less than J. And then you get Rij is equal to Qi star times Aj. And then, yeah, so we have this inequality, or we have this equation, and so this will be useful. Also, Qi star is a projector, because we know that that's true. And so we know that if you take I minus a projector, you also get a projector, so this is a projector. And so if you take I and then you subtract Q1 star, you get a projector. And then if you take that and subtract Q2 star, you get a projector. And then if you take that and subtract Q3 star, you get a projector. And you keep going until you get this sum, and you know that this is a projector. You could prove this through induction if you wanted to, but it's sort of a straightforward enough idea that it should be clear. But anyways, so this is a projector, and what happens if we take the star of this? Well, the star goes into the star of a sum is the sum of the stars. So we have I star, and then we have the sum of these stars. And so I star is I, and then, well, because, let's see here, if we take Qi star, then that becomes Qi star times Qi star, which is just Qi star. And so, not only is this a projector, but it's a Hermitian projector, and we know that Hermitian projectors are orthogonal projectors. And we proved earlier in exercise 6.5, so lecture 6, exercise 5, that the 2 norm of an orthogonal projector is always 1. So therefore, we can just do a whole bunch of estimates. So determinant of A is the determinant of the determinant of A is the determinant of Q times R, which is equal to the determinant of Q times the determinant of R, because the determinant of a product is the product of the determinants. And so from here we know the determinant of Q is 1, and we're left with the determinant of R in absolute value. And that looks like this, because we know that R is of this form. We've got, it's upper triangular, we got zeros down here, we got who cares what's up here, we've got these diagonal terms. If we take the determinant of this, if we expand along each of the columns, we'll see that we'll just get the product of the diagonal entries. That's a standard linear algebra fact, that the determinant of a upper triangular or lower triangular matrix is the product of the diagonal entries. So anyways, we have this, then standard inequality, this product is going to be less than or equal to this product. RJJ is a number, so this should actually be an equal to. Well, if it is equal, then in particular it's less than or equal to, so I guess I don't really care what it is, but just to be clear here, I should write that this is equals. And then this is equal, well, we have this form for RJJ, it looks like this and this, because we're just using this fact from up here. Okay, so what do we do from here? qi star times aj times qi, well, qi star times aj is just a scalar, so we can move it to the other side of qi, and so we end up with this, we have qi star ai. And now, no, that's a typo. This should be aj. Okay, I was scared for a minute, but this works out. So now we can factor out an aj on the right here, and we just get I minus the sum. And then, now this is a norm of a product of vectors, and the norm of a product of vectors is less than or equal to the product of the norms of the vectors. So here this is actually a less than or equal to, because we're dealing with matrices instead of just numbers. And so now we have the two, we still have this product, and we've got the 2 norm of this and the 2 norm of this. But we prove that these things are orthogonal projectors, and so their 2 norm is 1, and so we're left with just this. And hey, that's what we have at the end here. And so that's what we were trying to prove. And so we've proven Hadamard's inequality. And so we're done.